In this lesson, we will proceed in Grasshopper, trying to create something that is parametric, and we're gonna do like furniture. So in the previous video, we modeled this necklace, and we multiply a single element, and we divided the curve into many points, and then we distributed a sphere onto this curve. So essentially, when you want to do a model that contains a lot of copies, where you have a series of options here. And so I'm going to start with a sphere. I'm going to start with a simple example, and then we're going to see something a little bit more complex. So how do we create copies? We saw that we can create a list of values, and we can create points. I can decide to create things directly in Rhino without using Grasshopper, but in some cases this will be a disadvantage. So for example, if I want to array this sphere on a curve using Rhino arrays, I can open up the panels. And if you want to know more about Rhino, you can check the Rhino video course. So you have different types of arrays. You have rectangular, and then you have a volume, and then on a surface, and then on a path on a surface, and so on. So you have many options. So I'm going to go for a curve, and I need to record history if I want to have the possibility to go back and change the curve on which this will be distributed, and also if I want to change the sphere. And also you want to be more precise, well, as much as precise as you can when you create the well, any type of command concerning a path, like for example the sweep, etc., etc. So you can see now I selected the sphere, I selected the array on a curve, and now I need to choose a distance or the number of items. So if I can click, and you can see that the spheres are not actually going onto the path that we drawn onto the curve. So the curve is just a reference for the sphere that tells where the sphere where to go. So if you want to be more precise, you may want to use snaps, and you need to work like with the center of an object or with the edge. So here I'm putting this curve in the center of the sphere. As you can see, I'm using also the right view. So try also to help yourself with more than one view. And now if I do the same exact thing, so array on a path, and then click, let's modify here now the number, let's put like 5. You can see now, and let's change also the distance, let's say 20, and you can see now we have spheres that are evenly spaced into this curve on 20 units distance, and they are perfectly placed with the centers on the curve. So if you record history now and you move the points of the curve, as I'm doing, you can see that the sphere will adapt to that curve. And this is also a great functionality of Rhino. If I change the size of the sphere also, the others will change accordingly. And this is, again, thanks to record history. That's probably the only one way we can have this connection with the sources of that we use to create this array. So if I want to change the radius here or anything else, well, I need to actually resize or change the points position. So it's not really great when you have something complex to build, and also if you change operation, if you close and you reopen, you cannot retrieve those steps. So this is why Grasshopper is very useful, because everything will stay visually in the Canva here, so we can always go back and forward. We can do like reversible operation. So let's do the same exact thing or similar here in Grasshopper. So I can create a sphere from here instead of using Rhino, and I can change anytime the radius instead of like resizing. So I know perfectly which radius will be in terms of units. And also I can change, dynamically the result of the array or whatever else I'm going to create with the sphere. So if I look for brep, so why do I want to use brep? Because to make the reference, if I create a sphere in Rhino, to create the reference, I need to use the brep, because the sphere, you cannot set a sphere and that you created in Rhino. You either create it directly in Grasshopper or you just use the brep. If you use, again, like any type of sphere, you cannot connect it, and there is no like thing right here such a sphere that you can connect to the sphere in Rhino. So the only thing is brep. Brep is a generic shape, so you can use it with the box, so you can use it with the sphere or whatever. So it's the time to decide. Do I want to create a sphere in Rhino and then link it as a brep, or I want to use just Grasshopper? And in this case, we can see it's a little small, but we can change it, and we can change it dynamically. This is the the plus in Grasshopper, the advantage that if I go here, right click and edit this slider, and I say, okay, I want to go from 1 to 5, I can dynamically change the radius anytime. I can go back and forward so quick and so simple that, well, this is not possible in Rhino. So it's a little bit longer at the beginning because you need to put nodes, you need to define the values, the parameters, etc. But once you get it, it will be way easier to edit that composition or that thing you are building in Grasshopper. And we already explained this many times, but just to recap. So we have many ways we can like increase the number of things in Grasshopper. We saw the range, which is like creating a list. We saw the branches and the tree structure. Also here, if we go in the vector section, in the vector panel, we have things that we can use, which are like patterns or grids. So you have like basic rectangular pattern, and then so you can use it as it is, or you can assign some value and change it. I'm gonna use just the slider here just to show you that with that values I can affect also the grid. And this is like an hexagon grid, and right now these are just a series of lines or a series of shapes that are repeated, and you can decide the size and how many repetition you want to put. This is another one, and it's like a polar radial grid, which can be used also for polar arrays. And then you have another one here, triangle, which is another type of pattern, which can repeat it with the extents over and over again. And then you have also populate, which is like more random way to multiply elements or create copies and distribute. So let's say I want to use the sphere now. Let's start with this random 2D. You can see the points in there. So when you see that, you can use those points as a reference where to put the sphere, the original object, and also how to copy it. So if you have something that can be used, for example, we can use the base of the sphere, and you can see how many spheres now we have, and they're kind of intersecting with each other because they are bigger than the space between those points. I can lower down here the size, and you can see the bunch of sphere like randomly distributed. Or I can use a grid. I can use an hexagonal, rectangle grid, whatever, and they're gonna use, in this case, you see those empty slots, and those slots are gonna be filled with the spheres you can see here in the hexagon grid. So it's a way, again, to distribute, let's say, in 2-dimension this way. So not only on one curve, but on a sort of surface, which is not actually a surface, but it's a grid or a pattern. And also you can do in 3D. So in 3D, we're going to have volume, and you can already see the points distributed in the volume. And so if I want, I can put here anything that can be distributed, like a sphere can be distributed using the base command again, or the base parameter. And there you go. So we can see this box now is filled with spheres, and I can adjust, of course, anytime the count, or I can define a region. In this case, it's asking for a box, so I can put a box in there, and I can draw it, set it directly in Rhino like this,